Today's lecture is on storms. Let's go ahead and get started. So the topics today are hurricane damage, hurricane formation, impacts to the coast, and preparedness. So today is definitely a hurricane-centric take on storms because they're very relevant to this area of the world, and they're definitely one of the major storm types that humans have to prepare for and worry about. So I think it's good to focus on them. So the learning goals for today are to understand that there have been a few major hurricanes associated with a massive loss of life. How hurricanes form. So they begin as a low pressure area that moves through moisture-rich tropics and strengthens as heat is released through condensation in the atmosphere. You learn that storm surge is a rising of the sea as a result of atmospheric pressure changes and wind associated with the storm. And ultimately that we're pretty good at predicting some things about the hurricanes, like the future paths of hurricanes, but we're not so great at predicting changes in the intensity of storms. So hurricanes cause a massive amount of damage. I mean, that's why we're so interested in understanding how they form and their impacts. On average, hurricanes kill 20 people per year in the United States and cause about $5 billion worth of damage. So they're expensive and they cause loss of life. They're a hazard. There are some exceptional years that really stand out, such as 2005, where the death and damage totals greatly exceed average values. And of course, 2005 was the year that Hurricane Katrina hit New Orleans. And in fact, in 2005, 3 of the 10 strongest hurricanes ever observed in the North Atlantic occurred in that year. The deadliest hurricane in U.S. history is the Galveston hurricane in the year 1900, which caused 6,000 to 12,000 deaths. And you learned about that in your readings for this week. And the Great Hurricane of 1780, if we're looking at a worldwide scale in terms of destructive storms, the Great Hurricane of 1780 killed over 20,000 people in the Lesser Antilles. Historic rainfall amounts and flooding were associated with Hurricane Mitch in Honduras, Guatemala. There were 75 inches of rain in some locations, and that storm killed over 19,000 people in Honduras, Guatemala, and Nicaragua in 1998. So that one was relatively recent and caused a massive loss of life. This table over here is showing you the number of hurricanes that made a landfall in the U.S. each year, and the total number of hurricanes on record, and the number of deaths. Of course, 2005 stands out as a very exceptional year. How do hurricanes form? So hurricanes begin as a tropical wave. And a tropical wave is a low pressure area that moves through moisture-rich tropics. We know that this is the nucleus of a hurricane. It's a low-pressure system. It's moving through tropical areas. And as the weather system moves across the tropics, you get warm ocean air rising into the storm. And that strengthens the area of low pressure underneath, because as air is rising, pressure decreases. You actually have things moving up, so it's just like you would think. So as air is moving up, there's less pressure at sea level. And as air is rising, that causes something to come in to take its place, and the something is more air. So that causes more air to rush in. So we have air rising and air rushing in, creating those initial winds. As the rising air reaches the upper atmosphere, it cools and forms clouds and thunderstorms, and up in the clouds you get water condensing and forming droplets, and this releases even more heat and powers a storm. So ultimately, all of this heat, all of this movement of water and movement of wind just creates a powerhouse that strengthens a storm. So these are the steps Warm, moist air is moving over the ocean. Water vapor is rising. It cools and condenses into droplets, releasing heat into the atmosphere. And the warm air continues to rise, with moist air from the ocean taking its place and creating more wind. One of the major impacts of hurricanes that's so damaging to humans is the storm surge, because this is what we experience as a hurricane approaches shore. So the converging surface winds associated with a hurricane, as all those winds are moving towards the low pressure area, they sweep water along with them. They're basically just forming waves that are all converging in one area, and that causes the water to pile up in that area right underneath the storm. If the water is piling up, it can't just continue to pile up, it's also going to be under the force of gravity, and so that water will eventually have to go somewhere. And so water is sinking and returning out in return flow at deeper depths. As this pile of water gets closer and closer to shore, the return flow is condensed. It doesn't have as many places to go. The water doesn't have as many places to go, and so that piling up gets more and more pronounced, and the return flow gets stronger and stronger until eventually you're in an area where it's really shallow. You get a large pile of water, sometimes viewed as a massive wall of water, as you learned in your reading, and a really, really strong current heading out to sea. And this is the storm surge. The rising of the sea as a result of atmospheric pressure changes and wind associated with the storm. And as the storm surge approaches shore, it gets taller and taller, and that can cause massive problems for coastal communities. Hurricanes also move in a circular motion, and the reason for this is because of a phenomenon that you learned about in Intro to Oceanography, the Coriolis effect. And this is the observed curved path, that's hard to say, of moving objects relative to the surface of the Earth. This is due to the rotation of the Earth, and it assists in setting up the motion of a hurricane. As winds are moving towards the center of the hurricane, Coriolis effect in the northern hemisphere will deflect those winds to the right. And so you can see here a wind is approaching the eye of the storm, and it's deflected to the right. And this motion of deflection to the right sets up a counterclockwise circulation around the hurricane's low pressure system. So this is a cyclonic circulation. That's why these storms are called cyclones. And this, of course, is northern hemisphere centric. The opposite would be true in the southern hemisphere. If you've ever watched a storm approach shore, you'll notice that the highest storm surge is not where the center of the hurricane makes landfall. So it actually occurs somewhat north of where the eye of the storm is going to be making landfall. So as the storm is approaching the coast, the highest storm surge is occurring slightly northward of where the eye is going to make landfall on the coast. As you're watching a hurricane approach, you might hear people say, oh, we're in like the dangerous side of the hurricane. We're in the area where, the storm is going to be the strongest. And so you might wonder why are winds and storm surge worse on one side of the hurricane as compared to others? Well, the north side of the hurricane, or, if you're looking at a storm traveling in one direction, you might be looking at the right side of a hurricane, has the fastest winds. And the reason for this is because the direction of the motion of the hurricane, so here that would be 15 miles per hour, and the direction of the blowing winds, 100 miles per hour, are they're the same direction. They're both moving towards shore. Added together, those winds will be extra strong just because of the motion of the hurricane in the same direction as the winds are traveling. And so you expect to see the strongest winds and the highest storm surge in areas that are to the north of where the storm is heading, or to the right-hand side if the storm is heading north. On the south side, on the other hand, you get the winds traveling, because there's cyclonic motion, the winds are traveling out to sea. And so the movement of the storm and the wind traveling out to sea kind of cancels each other out. So here you'd see 85-mile-per-hour winds on the south side of the storm. And since winds are pushing water out in this location, you wouldn't see as bad of storm surge. So you're getting storm surge at a different point than the eye, because the strongest winds blowing in the direction of the coast will result in the highest storm surge. And this occurs if the storm is approaching coast like this. It'll occur north of where the eye of the hurricane makes landfall. When we're looking at hurricanes approach our coast, of course, those storms are oftentimes heading from the south to the north, and so then the most dangerous part is going to be on the right-hand side of where the hurricane makes landfall. This is kind of an East Coast-centric diagram because everything will be approaching from the Atlantic Ocean. So in your reading for today, you learned about the 1900 Galveston hurricane and how it was so devastating. And one of the reasons it was so deadly was that without radar and weather satellites, it wasn't possible to provide very much advance warning to people. Meteorologists really depended on surface observations of pressure, winds, and ocean waves, and they couldn't be everywhere at once, and they couldn't be on boats in a storm, and so that made the storm really hard to track. Now, of course, we have very, very good prediction capabilities because we have satellites. And we have a National Hurricane Center that's set up to monitor what's going on from satellite data. And they can monitor development, direction of motion, and strengthening of tropical storms as they move across the Atlantic. And then they can and do issue watches and warnings when a storm is starting to head in the direction of people. Predicting the future path of a hurricane can be difficult because hurricane movement is affected by nearby weather systems and the ocean, but we've become pretty good at predicting the path of a hurricane over time. So this image is showing you different forecast errors in miles between where a hurricane was forecasted to hit and where it actually hit from 1970 to the later 2000s. And these different colors, the bottom one here is a 24-hour forecast. You can see it's always been pretty close to correct in terms of forecasting the location of the storm. And then 48 hours and 72-hour forecast error is somewhat higher. So we've become a lot more consistent in forecasting the location of the storm and not getting very far off. So we've reduced forecast error over time, even for our longer, further out predictions. Predicting changes in the intensity of a hurricane still remains a problem. So that's much harder to predict. That happened several times for us this past hurricane season, where we thought we were going to get hit by a real doozy, and then it just kind of fizzled out as it approached the coast. And the opposite was true of the hurricane that hit in the Lake Charles area that was predicted to be a strong storm, but it ended up being an even stronger storm than people expected. And so that can go either way. We can predict changes in the intensity of a hurricane wrongly by overestimating its strength and also by underestimating its strength. There are many different impacts to the coast, and we've talked a little bit about storm damage in other portions of this course, and we'll continue to talk about storm damage, especially when we're covering things like climate change. But when we're talking about coastal systems, there are a number of things that can happen when a storm passes through. You can get short-term changes in salinity and increases in turbidity. And turbidity is the cloudiness or haziness of fluid. In this case, we would have increased cloudiness of the coastal water because of sediments kicked up by the storm. You can see mortality of some organisms. Most of the organisms in the Gulf are really, really, really good at dealing with storms. We worry constantly about hurricanes hitting the Keys and destroying habitat and causing loss of life for the key deer, but somehow all of these cute little key deer survive all of these hurricanes. So things in the Gulf are adapted to dealing with hurricanes, but you do get some losses. Like, for instance, if a hurricane happens shortly after sea turtle nesting season, you can get loss of sea turtle nests, and you can get death of organisms that are really sensitive to salinity extremes. And then, of course, we've just finished learning about barrier islands. You can get changes to the structure of the beach, dunes, or barrier islands. This image here is showing you, not the number of hurricanes. I feel like I gave you an older version of this PowerPoint, but, we're going to go with it. So this image here is showing you a new pass through a barrier island that happened after a hurricane hit. I believe this was the east coast of Florida, near St. Augustine. And then finally, hurricanes have been known to cause physical damage to oyster reefs. And these can take a really long time to self-repair, like on the order of 5 to 10 years. And so that can be kind of a big deal for our offshore protection by oyster reefs. Okay, let's do our quiz now. Just one question today. How does the rotation of a hurricane form? Answer this question from a Northern Hemisphere perspective. This is so zoomed in. Okay, so the correct answer was D. Coriolis force causes a rightward deflection in the winds that approach the low pressure system, which sets up a cyclonic circulation around the hurricane low pressure system. The other ones are not true, so hurricanes do actually rotate. The rotation is real. The converging winds do cause water to pile up, but it's not the return flow to the ocean that's causing the rotation. And the winds on the north side of the storm are indeed stronger than those on the south side, but that differential wind strength is a result of the circular motion of the winds, and it's not caused by it. It's nice work. Okay, I have a cool activity for you guys today, and it's under week 10, 16 in class. What we're going to do is play a game, and this is a game designed by the United Nations called Stop Disasters. And so you're going to be in charge of providing upgrades to an island community to help them survive an impending hurricane. And you're going to answer a couple of questions about your strategy after you get done with the game. So what I want to do is I want to start, and I'm going to give you guys 10 minutes to play through this simulation, and then we're all going to trigger our hurricanes, and it gives you a score at the end, and you guys can let me know your score, and whoever wins will get crowned the Grand Czar of Disaster. I don't really have any, rewards for you guys, but you get bragging rights at least. So anyway, this is in Top Hat. There's a link in there for you to play the game. I'm going to play along with you. And we will reconvene at so I'm gonna have us all trigger our disasters at 11:21, and then I'll give you time to answer your questions at the end. I'm gonna stop sharing so I can play. Yes, please do hurricane. Yep, please choose hurricane. Alright, go ahead and trigger your disaster. If you haven't already. And let me know what your score was. And because we're towards the end of class time, for some reason I had a brain fart and I thought that we ended at 11:30 today. I don't know. I'm losing it. So since we're at the end of class time, I'm just going to give everyone credit for your questions associated with this activity today. Oh man, does that matter? Do you need hospitals on the different islands? I guess you probably do. Yeah, I know. I know. I don't know. Maybe you do need one on each island. I thought you just needed one. Or did it get destroyed? Best worst score. Well, thanks for playing. I found that pretty fun when I found it a couple days ago. I got a little addicted for a little while. It does have some legit strategies for disaster, damage prevention in there, and so the questions relate to that, and so those will reappear on your list for exam questions. So, yeah, mangroves, so important. I wish they would let me do coral reef restoration, because there are coral reefs. Yeah, that's true. There might be more options the higher difficulty you go. Well, they could tip over a boat and shelter under that. That's good at least. They're unsheltered, but at least they won't get an oil drum to the head. Okay, I want to see what hard mode entails. I bet it just gives you more objectives. Yeah, I think it's just more objectives. Yeah, it doesn't look like there's any additional things you can do. It's just more people to house. Yeah. Alright, well, have fun being addicted to this game for a little while today, and I'm going to go ahead and end class. And there's no class on Friday because you guys have, I don't know, some holiday, spring break or something. So have fun with your mini spring break. Take a break from this class at least. And I will see you next week.